This conference will now be recorded.
Okay. Yesterday we have seen called threads, right? Similarly, here also we have called multiprocessing. Using multiprocessing also we can create the number of threads and we can run the program. So here we created one function called calculate square. If you pass a number
Oh, you're
of
not
a
sharing screen.
screen is not shared. I'm sharing. Can you see my screen now?
Yeah.
Okay. So we are passing some array of numbers. There is a function. Whenever you wanted to create a module, you can also check with underscore name equal to name. Then we need to run it. Okay. Now you have one function called calculate square. Means you have an array of numbers. Okay. When you pass to that array to this function, it has to print the numbers by calculating square of the number. Next, calculating cube of the number. Okay. One thread has to do squares, another thread has to do cubes. Okay. So here multiprocessing is another library which can create the threads by passing the function name to be called. So multiprocessing.process, you need to give the function name and then arguments. You are passing the arguments here. First argument is here numbers, here is a number. So that is what is the array value you are passing. Then you are starting the process 1, process 2. At the end, you need to close the join. Means whenever a process starts, always there is a life cycle. There's a start method and the stop method. Whenever you say process.join, now your threads are closed. See here.
Yeah.
So start the square of, okay, first the square of 2, square of 3, square of 8. So 2, 3, and then 8. It is printed. Now the second process, cube of 2, 3, and 7. Then all the threads are closed. This is how multiple processes can be created. That is using processing, right? Multiprocessing is a module. Means this is a library you are using. What if you create threads? So threading is a module name in which you wanted to create the same program by using threads. So threading.thread, target is your function name and arguments is your array, same array you are passing. But in multiprocessing, you can't switch between the process. Okay, switching is not possible. Once one process is completed, only the other process can start. But in multi-threading, what we can do is, while one thread is doing some logic, it can go to sleep of 1 second. Means by the time the first thread is going to sleep, other thread can share the resources and then it can execute the program. So here now 2 threads are started. Okay. Now thread 1, thread 2. So again alternately it is doing. Earlier process means what it is doing. If it is a multiprocessing, it is doing one after the other. Whereas threads means it can do parallelly. This is what we need because to share the resources. Suppose if you increase the sleep time, right? So if you make it, so we can increase the sleep time if you make them to run slow. Is it clear the difference between multiprocessing and multithreading?
Yeah.
So threading, switching is possible, processing it is not possible. So suppose if you wanted to perform synchronization. Synchronization means what? Suppose if there is a balance amount 200 and you have two processes. One process is adding the amount. Balance amount should be added. Okay. And withdraw amount is deducting the amount. It may be 1 hour, whatever you pass. Okay. But whenever you do deposit and withdrawal, the common amount you are doing, what is the balance amount? 200. Okay. In the 200 amount, if I call multiprocessing dot deposit amount, it should become 201, right? It should become 201. And whenever you call this, okay, it should again become 200 because 201 minus 1, 200. When two processes are started, if you are not using locking mechanism, if there is no lock, there is a concurrency issue. Means by the time one thread started, it increments, other thread started, it decrements. Okay, let me show you. If there is no lock, how it behaves, we have to see. Here we need to create a lock object and here we need to acquire it. At the beginning of the thread, it should acquire and at the end, it should be released. Now there is no locking, right? And just like previous example, you are calling it. But that is doing square and cube and it is doing increment and decrement.
Right.
See here, there's a log somewhere we are passing the log here. Now it can do deposit withdrawal,
Yeah.
but there is no control. Just it is doing 200. That's it. It is not properly calling your deposit. We are calling deposit. So it called deposit. 201 is done. Then withdrawal. It is again deducted. So it is showing 200. But we wanted to call them multiple times. Okay. So in that
Yeah.
case, a logging should be done. So make a log first. Okay. And pass the log here so that it will acquire a log on a multiprocessed object and then properly it will control the application. Save it. Now it is going to print the value. Okay. Suppose if you call it many times, you are calling with this and you're not. There is a single process, let's say. Means only you're incrementing, you're depositing, but you're not withdrawing. then it should show 200 plus balance amount is 200, and here we are, how many times we are depositing? 100 times.
Yeah.
So 300, right?
Yeah.
Now, when we call this withdraw for again, it executes 100 times, it reduce the amount and again it will become 200.
Mm.
Okay. This is using lock and unlock mechanism. Locking means while one thread is doing some job, while this is executing thread, first thread deposit, it should not interfere by the other thread. Means the second should not start because we are creating a lock and we are acquiring the lock. If there is no locking mechanism, okay, then both the threads are started, then there is a chance of race condition. So maybe partially the deposit functionality and balance functionality will be executed. That's the reason we use this lock and unlock mechanism. The very first one is without lock and unlock. This is with the lock and unlock. This is while multiple threads are operating on a common data. To avoid the race condition, we use this locking and unlocking. Next is you wanted to create an object, multi-thread object with a pool of objects. Means let's say 3 objects you wanted to create at a time. In case of all the previous example, you want 2 threads, D and W. Here you want 2 threads, T1 and T2. Every time you are creating individual thread. Suppose here you want 2 processes, process 1, process 2. But similarly, what if I need more number of threads? You cannot create one by one. So we can say pool. Pool is another object which is coming from the library.
Mm.
Pool of processors, if you say 3 processes are created. And each process is just mapped with a given input. What is the input here? Input function is f. Function name can be anything. And you are passing a number. So number, it is an array of numbers. So it takes that number as an input and it returns square of the number. And then that is the numbers you are going to print it. Okay. So this is called creating multiple threads by using pools. Means a pool of threads are created. There are 3 threads. Okay. So here you can see it is the task is divided by 3 processes inside. It may be any number of processes 1, 2, 4, 16, 20. Suppose if I have many number, now I wanted to divide the task by 5 threads, 5 processes. Yes, it is possible. You get the output. The number of processes you need to decide. The task is divided by 5 processes, so it can be done faster. Suppose if I take only 2 processes, okay, you get the output, but it will maybe divided by 2 processes, so it will be slow. Clear, Anir?
Yeah.
This is all the different libraries we are using for uh, multi-threading. Pool, process, lock. The same thing is explained here. Okay, same application, no change. Now some more thread examples. So threading is a library. Now you have function called print series. A range of numbers should be printed with a break of 2. Now to print this print series, you wanted to assign to a task, to a thread. So threading dot thread of target is your print series is a function. And what is the number of threads you created you wanted to see. Though, so active count, if you say, it will say how many threads are created. So here you can see range 0 to 10 increment by 2 every time. Start is going to start your thread, join is at the end of your thread, it should be closed. Suppose what if I wanted to create one more thread? So T2 equal to threading dot thread of same target I wanted to give equal to print series. Means same function, but I want to create another thread. So done. Now you wanted to start. After starting, you give active count. Okay. So T1 dot start, T2 dot start. So two threads are started. Now at the end of your application, they should be joined. T2 dot
T2
join.
join.
So that all the threads are created.
What do these threads do?
Yes, start actually will start your thread.
Mm,
If you don't start it, they cannot execute.
um,
Though object is created, it can't run. Okay, suppose if you see, you created the thread, but you're not starting it. To trigger the thread, we need that start. Okay, it's not
yeah.
getting started. Unless until you give start, it won't run. So join is not mandatory. It means you have started used, but you are coming out of the program without closing them. That is not correct, right? You have to close it. That's the reason join is used. Is it clear? Start
Yeah.
and join. Next is called, here also you're printing by multiple threads. The same thing, but you just can convert printing a time. Okay. So print the current time while passing with the starting with the 2 delay. So it is going to display time dot current time dot time with the delay. Means in the previous program only we will say print
What does active count do? Threading dot active count.
active count will give the number of threads.
Oh, okay.
Number of threads created. Okay.
Yeah.
This thing let us print. So current time you wanted to print, and every time you wanted to give a delay. While printing the time. Okay.
Yeah.
That's it. Now if you go and print it, it's printing the time, right? Date and time. So this is how you can make use of multi-threading related logics. Thread 2 is also combined with thread 1. Now here, let's say you have to do two different tasks, okay? But if you do two different tasks with a single, without thread, it may take more time. Let's say 1 minute time it is taking. Now you guys can divide the task by two threads. One task is printing even numbers, another task is printing odd numbers. From 0 to 20 only, you have to print even numbers, then odd numbers. If you divide this task into two different threads, thread 1, thread 2, it is printing even, second one is printing odd. Now both are started, both are joined. Such a way you have to use multi-threading to divide the task into number of threads so that all the numbers are printed. Odd thread is printing odd numbers, even thread is printing all even numbers. So your task is finished, right? So this is
Yeah.
how you can enable multi-programming, multi-threaded programming to make your applications much faster, to reduce the response time and make it more dynamic. Okay.
Okay.
Yeah. So here also similar thing. So here what we are doing is we are creating two threads. So thread name here, my thread. So my thread, and in which you are passing the name of the thread. So generally name of the thread is optional. If you wanted to print the name, you can print the name of the thread. And you are printing the count. So what is a count here? Like 1 to 6 you have to print the numbers. Okay. So in a thread object, generally when we create a class, parent class we are taking called threading.thread. This is called creating a custom thread. Here in all the previous examples also we are creating a thread only. So that is simply you are saying that threading.thread, if you say thread object is created, you are passing the function into that. There is another way to create a thread is called write a class extend thread class. What is this? When we write something inside the bracket that defines super class, right? Remember inheritance? So when you pass the parent object over here, it will become a thread class. My thread is called as a child thread and it is called as a custom thread. Once if you create a custom thread, okay, you can initialize that custom thread. Initializing means what? You know, right? Constructor.
Yeah.
So we create the constructor, we are passing the name of the thread. Means whenever we create a thread object, first we pass this constructor name. So that is coming into this name. Here name of the thread is thread 2. So thread
Yeah.
2 will store. Now there is a run function. Run is a
Wait, what is
function.
self?
Sorry?
Self, like
Yeah.
self
Self
name.
is we have to use in constructor, right?
Yeah. Oh, oh, okay, okay.
Constructor
Yeah.
we need to
You
pass.
have to always use self and then
Yeah.
pass it.
So self dot name means the name that we pass. Here you can give any name. Okay. Let's say
Okay.
thread name I am giving Anir1 and thread 2 is Anir2. Like this.
Hmm.
Two child threads are created. But each thread, how many times it is running? 6 times.
Yeah, 6 times.
6 times it has to print. Okay. And then the name of the thread is printed at the end. So that is what we are starting two threads and we are printing. And run. Run is a implicit function. This is thread function. It should be run only. Whenever you say thread object creation, after that when you say start, this will call your run method. It internally calls your run method.
Okay.
Also, it calls run method. Okay, save it. Now you see, save. See, starting Anir 1, Anir 2.
Hmm.
Thread name Anir 1, 1, Anir 2, 1. Again Anir 1, 2, Anir 2, 2. Again 3. Likewise, it
Oh, it just
prints.
keeps going and going.
Yes.
Wait, so what is the count? What part is that? Do you get the
Count
count?
is count is nothing but this number.
Oh, self dot name count.
Yes.
Oh, and then it'll only go to 6.
Yeah. 1 to 6, right?
Yeah.
It is less than 6, it is.
Oh, so it doesn't do 6. It does 1, 2, 3, 4, 5.
Yes. Yes.
Okay. So 5 times.
Okay.
Yeah.
This is called creating a threads, custom thread. Previous way also creating a thread only, but here we are creating a custom thread. I will push all these programs into the GitHub.
Okay.
Next, thread pool app. Pool of thread is nothing but, see, in all the previous programs, we are creating a simply a thread object and we are starting it and we are joining. In the pool, what happens? You can create a number of threads at a time. See here, as usual, there is a square function that should print a square of numbers, cube function that should print a cube of numbers. Okay, means for val in numbers, val into val means every time it is calculating square. Then you're taking a sleep of 1 minute, 1 second, and then you're printing. Here, cube is printing cube of numbers. Now, what are you doing here is you make an array of some numbers, 5 numbers. It has to do for 5 numbers. This function has to do for 5 numbers. Now, you wanted to divide this task to number of threads. Then you create a pool executor. In all the previous programs, what are we doing? Thread 1, thread 2, like this, you are creating explicitly. Suppose if you wanted to divide the task to multiple threads, thread 3, thread 4, you have to create. But in the pool, the advantage is, okay, we can create a number of threads at a time. 4 threads are created. And executor dot submit of directly. Each executor dot submit will take a task. So first function square, pass the array input. Second function cube, pass the input. So from the available 4 threads, any of the thread will take this task. Any of the available thread will take this task and it starts execution. Once all the threads are completed its execution, you can check with is done. If done is true, then it stops. And if you wanted to take a break in between, sleep in between, take it the sleep. Okay. So So it has done all the logics by both the threads. Thread 1 is doing some job. Thread 2 is completed, executed false. Means initially you are checking whether it is started or not. So is executed is false initially. Then it starts execution. After starting execution, it is printing the values. Number 1, cube 1, square 1, cube 8. Again the thread you are checking with executed is false. Okay. After when you give sleep time, we are checking whether it is executed. When it is sleeping, it is not executing. Okay. Again, after 2 minutes, 2 seconds is completed, it will come back. It start execution. So now again it continues. So checking whether it is running or not is done method. You make explicitly thread to sleep. It is going to sleep for 2 seconds and then it is continuing. Suppose if you comment this, there is no sleep. Okay, simply it will perform all the logic and then it will say done. See, initially it is false. Now it continuously does the logic. Okay, clear?
Yeah, clear.
Yeah. This is how we can check with the thread pool. Okay, this is all about the multi-threading related programs. So let me create folder. This is all not required, but these things are needed. So we copied. And one more is okay. So this is all the programs we were doing now.
Yeah.
And one last application is sync app, synchronization. So synchronization means, let's say you are creating two threads, thread 1, thread 2. You are passing a number to both the threads. So my thread, it is taking first name of the thread, and then thread name and counter, everything is initialized. Now in the run method, it is starting the thread. Whenever it starts, first it is printing the name of the thread, counter. What is the counter value you are sending? And then 3. 3 is a counter. Now print time. Time means it takes some sleep time and it print the current time. Counter is -1. Means every time it is decrementing by 1. If two threads are printing, two times it is going to,
Wait, what is one, third one, and then one?
yeah, thread 1. This one you're saying underscore 1. No? This one,
No, up more.
here,
Like
this one.
28,
It's a
yeah.
thread name. It's a thread name.
No, but what is one? Like in the first part, it
1
says
and 2.
one.
1 and 2 is a thread name. So first one is, there is a thread ID is
Oh,
created
thread
by
ID, name,
thread
counter.
ID.
What is the counter?
Counter is just a variable we are taking
Oh,
as
so it
if,
just keeps increasing.
yes.
Or is it
And then,
decreasing in this one?
yes, this is the name of the thread, this is a counter, and this is a
Hmm.
thread ID.
Okay. Why is it starting at 2 though?
Why it is starting with the
2.
2 is a counter. Second thread should execute 2 times. First thread
Uh,
should execute 1 time.
okay.
Now, along with the timestamp, you have to create the thread, right? So both are taking the same delay, and you have to acquire the lock and release the lock, right? So
Yeah.
to do this proper synchronization, we will do like when we start both the threads, thread lock you should acquire and you should release the lock. So threads dot append you are saying. Append means what? We are joining the threads.
Yeah,
Thread
you're
one,
adding
thread.
it, right?
So one after the other, both should execute. And
Isn't it
after,
append for list?
yeah, this is like a,
Yeah.
you're just like creating a list of thread objects,
Okay.
array of threads object, and you're
Oh,
appending
yeah, yeah.
both of them, and you're executing with the loop. At the end of your application, all the threads should be joined. So instead of that, what you have to do? Thread 1 dot join, thread 2 dot join, you have to give. If I add everything into the list, I can take that list and I can join them together, right? That is called join method.
Okay.
Yeah. This is one more application called synchronized application. So properly it is synchronizing and it is executing. Once it is done with all the methods, then it will close. So let me pop sync app also here. GitHub. Threads, right? In the same threads itself, I'll upload all the files.
Okay.
Do you have any questions?
No.
So with this threads concept is completed. Multi-threading concept means this is especially when we are working with like gaming related application and you need to distribute some intensive applications to multiple
Hmm.
threads. That time we use this multi-threading concept.
Okay.
Actually, we have another concept, a small feature called as logging. Logging means in your application, generally we should try to avoid printing everything in the console. Mostly what we will do is we create a logging object so that it will create a file and into which it will log the file. There is some log, right? Let me remove this. All the content I removed and I saved. Sample.log. Now what my log application will do is, see here is, first I'm making my class logger, logging equal to get logger of name. So here logging is implicit library. What exactly this logging will do? Whenever you are executing some task in your application, okay, in between, let's say your program is running so many functions, so many threads and all. If
Yeah.
in between what is happening, you have to track. Every time you cannot say print statement. So that if you give print statement, every time it is printing in the console, along with the output, these print statements are also coming, right? But I don't want it to print in the console. I have to log into a file so that once my program is executed, later point in time, I will open my log. I wanted to see what is the flow of my application. Sometime it may fail in between. Why it is failed? I can look into my log. If it is successfully executed, proper flow of my execution. Again, I will look into my log. Okay, that is how logger is used.
I
Logging is nothing but the monitoring and controlling the entire flow of application and writing that logging statements into a logger. That is
okay.
called as logger. So logging is a library. First, you need to create a logging object. Logging.basic log of what type of logging it is. Sometimes you wanted to log only information means like print statement. Logging of warning, logging of error, fatal error, logging for debugging. Like various levels are there in the logging. Next is format of the login. While it is writing into the log file, what is the format? Let's say time, level of the log, and then message. This is called as the format of the logger. The way you write it. Only if you say message, only message will be printed, time and level is not printed. Okay. Now, I have a simple function called a plus b. If I pass a comma b, I have to first check 10 by 0. There is a divide by 0, right? There is some exception is happening. And then first I am printing sum of a plus b. Then I am calculating it. Then I am printing it. But in between there is an exception. Okay. If there is no exception, it properly calculate the sum and give the result. That is what is my function. Next, in the main program, what are you doing? First, you are making the file handler, means into which file it has to create. Let me delete this file. Sample.log is deleted. But whenever I run this program, again it create this file. Okay. Let's say here I will say anirba.log. Anirba log file dot log. Okay. Now a file is created. Then formatting it is setting. Formatter is set. Then add handler means you need to add that file handler. Done. Now you are starting your program. What is your program? You need to suppose to call this function. So call that calculate sum of 10 comma 20. When you call it, it is going to perform some of the numbers and it has to print. Okay, but in between there is an exception. Let's say there is no exception. Let's say 10 by 2, right? If there is no exception, it should come in a different way. That flow it will print by using logger. See here, first it started the program. It is printing. Successfully it is printing the number 10 plus 20 30, and then program is come. This is what it is printing at the console. Again, if you see anirba.log file, there is a file created in which your log is done. Everything is created. What if there is an exception in my program? Means I am dividing it by 0. So program will not execute successfully, right? That also should be logged. Again, I run my program. Now it says, Okay, there's a divide by 0, and then after it is calculating sum, then it is printing it. Now if you go to the log file, it is logging again. Whenever you run the program, it get logged every time. Okay, suppose in the same file, I'm not doing this try catch. I'm not doing try catch means there is no try and accept. Okay, simply you have 10 by 0 and printing it. What happened? There is no try except it terminates, right? So that also, before that it was logging starting, but later it is terminating, right? The same thing is also logged into this. Started is done, but ending is not done. So everything you can track it, like is it going in a proper flow or not. Okay. So that is the purpose of logging. Is that clear?
Yeah.
There is one more logging application. Here also the same process. First you are creating a logging object. Formatting you need to set. File name is here my sample 123 log. Here function started. Your function name is getEMI. Just you are calling that getEMI function. It print my EMI is so and so. Logger is begin. Logger is started. Here also begin started. Simply to observe the logging here. Whenever you run the program, so your output is you're getting through print method. But other logger info, everything is created into this my sample 123.log. And it is not created.
What happens in the text file?
In the text file, it got created. It has to return. I think something file handler or something is missing.
Yeah.
Logger.handler is done.
So what goes in it?
Mm. Set formatter, we have we set formatter, add handler, dot info. Set formatter we gave and handler we gave. Let's give the same thing. This is log 1 we will give. So logger. Okay. Here log file 1 we are giving. Set it. Click and run. Now it got logged and enable log file 1 is created. It is not appending, right?
No.
Log.info. Whereas this is writing. You just check with the both the files, okay? So here it is divided by 0. Let me make it try. Then it is writing it. So it's going here every time it is writing. But in log app 2, you can check with what is the difference here. Underscore underscore name. After log handler. This entire thing give in the same order.
Oh, so it's just printing in the other file.
Yeah. We will give it in the same order. Logging get logger. Then this is file 2 and then logger. Save it and run. Log file 2. Yeah, somehow it is not writing into the file. You need to check that. Okay. Or else take the first example only. This is how you can perform logging. Suppose there is an application without log. Here you're just simply creating a function and calling it. And take this example and take this logger objects. Okay. Take this logger, everything you need to create. This is a logger. I think configuration is not done. This is missing, I think. This file. Yeah. Basic configuration is not done. That's the reason it is not writing.
Oh,
Yeah, now it is coming. Now if you take this file, it is writing. Okay. Similarly, if you wanted to do it for a new file, right? So first you add this import logging and logging. So there's a function without log. First you import it. So basic logging is done. Now here you just wanted to create that logger object. So take it, all these steps. So logger, file handler, formatter, add handler.
yeah.
Okay. These things you have to write here. Then you wanted to log your application. Before log, here logger.info and say started. After printing, stopped. Okay. Simply you just wanted to give this message. But the file name is you wanted to give enable logger file 4. Now when you run this, you will
It'll
execute the
print it
output
in the file.
printed and this file is printed.
Wait, will it create the file or do you have to create the file yourself?
Create the file. No, it create the file automatically.
Okay.
Okay. So these three things also I am including in the uh,
That multi-thread.
folder. I'll make it as login. Okay. And I'll make all the files in that. Easy for reference.
Okay.
Three files. Okay, I'll just upload this folder. That's all for today. Have any questions?
Nope, that's it.
Okay then.
Okay,
Yeah,
thank you.
have a good day.
Yep, you too.
Bye.
Bye.